And we are live. Hello! I'm pretty much on time, to my great surprise. Just really quickly, doing a few pokes to people. There we go. I made a few call outs to a few people in the hopes that someone decides to drop by. I know a few wanted to in the past, but either canceled the stream or they missed it. So there we go. Cool beans. So we have our amazing desk over here that somehow doesn't look half bad. Yeah, I kind of like it. I'm not gonna lie, I like it. It's a good one. Even got a little normal map going. The bit of a strange smudge there, but that's fine. It's fine. All right, I'm just gonna make sure that my live chat is set to live chat. Let's see, what else are we missing here? Are we missing anything? I don't think so. I think we're good. Yeah. So, hello and welcome to the stream that we had to skip last week. The idea originally was that I was going to have a stream, but I found out the hard way that a weekend of going to a convention actually does take a toll on you. So, yeah, skip that night, here tonight. And we are going to continue working on the wardrobe. So we do have our wardrobe here. Cabinet, sorry, I called it cabinet, with the drawer that we can open and close. We have the doors that we can also, well, not in the same way, but we could also open and close. So what I'm thinking is I've been thinking about it like on the side for 2 weeks now. It's been taking up a lot of brain space, so I want to get it out in the open. I want to rework how we're doing hinge joints for these, and also do something for this so that when we're in VR, I'll be able to go down, grab this, and pull this out, and there's going to be like a point at which it stops, and then I can close it as well. And I want to do the same thing for these doors that are going to swing open and close, or at least that's the plan. Now I have a few things working against me for this here. As you can see right now, if we select the door and we try to rotate it, it rotates from the center of the door. There's a few things I can do for this. I think the obvious thing is the best thing for me to do at first, but we'll probably use a bit of code. So the obvious thing to do here would be to pop open Blender again, and we're going to change where that pivot point is for that door. I'm fairly certain that is something we can do. So let's go into house. Yeah, we got to remember the keys for Blender. We're good. Going to select the cabinet door. Oh, we're in painting mode. Right. Modeling mode. Here we go. So let's get out of the polygon editing mode. And what we're going to do, let's see, local, global, gimbal. Each axis to the Euler rotation, no. View, cursor. Isn't there a way to be able to choose where the pivot point is for that? I think there is. Let's go take a quick look. So, Blender, object, pivot point. How to change the pivot point in Blender. Fantastic. To change the pivot point in Blender's viewport, that might not be what we're looking for actually, but that's fine. Go to the center of the header section and find the transform pivot point menu between the transform orientation options and snapping tools. Click it and choose the element you want to set a pivot point. Okay. So default gizmo, gimbal normals, global, object type. I don't think that's what we want. Orientation. Yeah, that's fine. Object mode, edit mode, sculpt mode, vertex plate. None of that is what we want. All right. Okay. Okay, by default, the pivot point is set to the origin of the object, which is the orange dot placed at the center of your object. Okay, but we can use many pivot points. So this is called the origin of the object, and that's probably actually what we want to do. Okay, let's see. So, this, they want us to go here, transform pivot. Oh, that's exactly what we want. Okay. Or is it? Bounding box center, 3D cursor, individual origins. No. Active element. No, that's not what I want at all. Pivot point origin, object origin. Okay, let's see if we could change the origin of the object. So, object origin. Blender. Yep. Okay. Let's see, what does this tell us? Each object has an origin point. The location of the point determines where the object is located in 3D space. When an object is selected, a small circle appears, denoting the origin point. The location of the origin point is important for translating, rotating, blah, 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 blah. See pivot points for more. Yeah, we're aware of this. The color of the origin changed on the selection state of the object. Okay. Set origin. Okay. The object origin and geometry can be moved relative to each other and to the 3D cursor. Okay. Type geometry to origin, origin to geometry, origin to 3D cursor, origin to center of mass. This is object set origin. Okay, let's take a look. So we've selected this. Let's go up to here, object set origin. Sets the object origin by either moving the data or the set center of data to the 3D cursor. Okay, that's, if I'm not mistaken, that thing down there. Okay. What else do we have here? Volume, mass, origin to geometry, geometry to origin. Okay. So, let's just do a real quick test. Set origin. To 3D cursor. Yeah, it has moved it down to here. Wonderful. So, what we need to do now is find out how to move the cursor. Okay. Blender. Move 3D cursor. The shortcut to move the 3D cursor in Blender is Shift and right click with the mouse. If we click onto an object, the 3D cursor will snap onto the surface of the object. If we click onto a 3D space, okay. So Shift and right click with the mouse. Oh yeah, look at that. Oh, that's wonderful. Okay. We want a little bit more control than that though. Let's... Oh, I was gonna say let's go back. We can't actually go back for that. Okay, good to know. How to move the 3D cursor in Blender. You can shift right click, that's fine. Use the move 3D cursor. Okay. It's up here. Okay. And we can move that to like over here. And we actually do have control over it. All right. So, whoa, no, undo. Oh no. Okay. Let's bring this back. Bring that back right there. Okay. we're just gonna do this. We're just gonna move it a little bit, right like that. And just tip. No, 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 no. Tap. No, 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 no. Shift. Click once more. Let's see. X, Y, and Z. Z is what we want. Okay. No, 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 no. Shift click might be the best. Might be the best thing for us right now. Alright, well, what else do we have here? Select cursor. Cursor to selected. Cursor to grid. Yeah. Okay. The rest, not that important. Okay. So that doesn't give us a lot of control is the problem. That looks fine though. That's fine, I guess. Okay. Right, so now if I click object, select origin to cursor, it moves it over here. We're going to test it. We're going to do that over here. We're just going to shift right click. Can I get it just a little closer to the edge there? That'll do. And then we're also going to do set origin to 3D cursor over here. So the origin is here on that door, and the origin is here on that door. Do we want that for the drawer? No, it can stay in the middle, I think. Okay. Alrighty. So we're going to select the entire cabinet, give it a save. Before I forget, go over to export, FBX. No, we do not want this to raw data. See, raw asset is not what we want. We're going to go over to art, 3D, environment, yes, house. Wooden cabinet. Okay, so mesh, selected objects only, apply transform, why not? Let's take the bake off and just leave everything as default otherwise. Give it a save, and we're going to go back to Unity. And it looks like that's exactly what we wanted. So now if we rotate the door, it does actually rotate at a good place. Maybe not the right place, but at a pretty good place. All right. And same on the other side. Yeah, look at this. Oh, yeah. Okay. That was thing number one. And that means that it should just rotate better, generally, when we're going to be working with it later. So here's the idea, right? I want to create a couple of components for this cabinet. And the idea is that I want to be able to reuse those components later on my actual doors, because I do not like these hinge joint systems. I want to be able to have a clear delimitation of where the door can start moving, where the door can stop moving. I want to have it so that when it gets to an extremity, if you let go of it, it doesn't start like moving back slowly. It stays there. It wants to stay there. It kind of clamps in place if it's not moving too fast. And all of that I can't currently do on the hinge joint stuff. So tonight we're going to start working on this, and I expect it's going to take more than 2 hours, because we want to have a system that will be able to deal with interactions like this with minimum, maximum, like movements parameters, I guess is the word I'm looking for. And then on top of it, I want it to interact in VR. So those are two separate things. Let's start with just getting something for the door, and then we'll deal with the drawer after. So we can close the art for now. Close all that. Prefabs as well. Scripts is what we want. It's been a little while since I've been in Unity. It's been like 2 weeks. I'm realizing that it's easy enough to get back into, but it is taking me a few seconds to like remember where everything is, mostly in my own project. Okay, so we have scripts, we have environment. Look at this, we have a door script. Let me have a think here. Do we want it to be in the doors folder? I guess we could always move it after. Let's go ahead and put it in the doors folder. Door handle follower. Yeah. We might still use that. I'm not sure. But not in the same way. So let's go ahead and create ourselves a new C# script. And let's call it... I was going to call it limited interaction. That's not quite what we want. Limited movement. Let me see. Naming is always half the battle. Interactable movement limiter. Let's do that. Interactable movement limiter. Very nice, simple name. And I'm pretty sure Tor is not how I should have spelled that. Let me see. Limitor. I don't know. Apparently that is a thing. First person, single person. Oh, it's not English. That's what it is. It's like Latin. Okay, but that's fine. Limiter. Let's name this right. It's gonna rename it. I guess I could still rename it. Yeah. Let's do that. Limiter. Like that. And just copy that because I believe in Unity it doesn't rename things, which is actually a nice thing. And hello to new viewer. Welcome to stream. We're doing some nice, relaxing, probably mathematics tonight. So this should be fun. Right. So let's have an onDraw. OnDraw gizmo selected? You want the draw gizmo only if the object is selected. You know what? Let's do that. We are going to... We're going to start by only dealing with... Oh, it's Joe! Hey, Joe. We're going to start with only dealing with some rotations. So let's do that for now. I have my microphone set up in a way that I can't actually see my keyboard. There we go, this is a bit better. Serialized field, let's have a little private. Vector 3. And we'll call this rotation origin? Movement origin? Origin? It's called movement origin. There we go. This is going to be the initial point. And then we're also going to have like, let's pop out our best friend's paint here. There we go. So we have our door, right? As such. And what I want to do is I want to select a origin position. So it'll be like here, I guess. And then I want to be able to tell it, okay, you are going to start at this rotation. And then I want to also allow you to, you know, rotate to like all the way over here. Right? So it'll start there, and then when you start interacting with it, it can go all the way over there. So this will essentially be the minimum value of the rotation. This will be the maximum value of the rotation. And hello, other new person. I'm seeing like YouTube is actually being responsive tonight. I'm seeing people pop in, which is pretty cool. Okay, so maybe what I want is a minimum minimum rotation, maximum rotation. Let me see. Okay, so there's a few things I could do. Like my brain is currently buzzing. I'm thinking what could be cool is that we directly in editor like place it how we want, and then we could set the value and then set the maximum value, and it keeps that. Oh hey, it's in. It keeps that in memory, because I think that'd be fun. But let's keep it simple at first. Let's just deal with the rotations. Okay, so private, this can be a vector 3 as well. And this will be min rotation. And we'll deal with like other settings afterwards, I think. Serialize field. Private. How's the sound, by the way? I had to change where the like on-screen sound, I guess it is on OBS, and I have no idea if it's coming in well or if it's a little choppier stuff, because it is going through my switch, the new switch I have, not the console, the like switch between computers thing. Max rotation. So the minimum rotation, the maximum rotation. All right. So what we're going to do is on draw gizmo, we're going to show that in a way. It's great. Good to hear. Good to hear. And I guess that goes for my voice as well, because I did move my mic a little bit off, so I could actually see my keyboard. Oh boy. Okay. Hello everybody. There's quite a few people that is joining now. Cool. On draw gizmo selected. Let's start with gizmos. Oh, it's been a little while since I've done this. Gizmos.color, right. Draw cube, right. Draw line. Draw mesh, draw ray, draw sphere. There's also one for wire, I think. Wire sphere. Yeah, let's start with that. Let's start with that. As I said, it has actually been a little while since I've been playing around with Unity on a daily basis, I'm realizing. So movement origin, that's going to be what we want. Movement origin. And we want a radius, so let's just put 0.1f for now. And I think I should be able to decide the color with this, so let's do gizmos.color. Right, and this will be equal to color. What color are we feeling like? Green? Cyan? Let's go with cyan. No one ever chooses cyan, right? It's a good color. It deserves more love. Okay. Here we go, and we're going to add the limiter here. Good. Ooh, good point. Okay. So right now I did add this on, and it should, let's just double check, it should be adding a gizmo somewhere. The thing is, I think 0 is actually down there somewhere. So what we're going to do is go back over to our code for a second, and instead of doing movement origin, we're going to do movement origin. You know what? Actually, we're going to do transform dot position plus movement origin. Yeah, I hear you love Unreal and want to switch over to that engine because everything is so much easier and stable and has no weird bugs whatsoever. Don't get me started on the weird bugs, man. Don't get me started. You would not believe the acrobatics I'm currently doing. But here's our gizmo. And look, it's you know, this is what sucks about Unity, right? You go into your code, you change something, you go back into your scene, and it just works. Like, how difficult is that? I'm not going to complain any more than that. But yes, I have been swearing quite a bit recently on Unreal, and Etienne has the displeasure to hear me throughout the day. It's you know, it's a cool engine. It has some cool features and stuff, but I'm just so used to Unity. I'm sure that makes everything worse, but yeah. Anyway, so here we go. We got a gizmo that shows the location we want the rotation to start from, and now we're going to oh no. 2 plus 2 equals 50, right? Because you always round up to the closest 50th number, right? Okay. I haven't heard that one before. What code is that? In the Unreal Engine, it's C++. Hypothetically, Unreal Engine does come with like a blueprint system that it's like a node-based coding system. Let me see if I can show you a little bit what it looks like. So yeah, it has this you know, visual coding system that also exists in Unreal, and I actually kind of like it. Like, I really enjoyed coding with this, but what I found out is, one, you can't do peer review code on this. It's hell. And two, it's a lot less optimized than if you just coded in C++ to start with. So yeah, you might as well just use C++. Unreal, ain't that Unity? Oh, you mean here? This is Unity, yes. And this is C#. You didn't show me some weird thing where Unreal rounded up to number for you and gave you weird results. Oh, okay. I probably. There's some weirder things that I've seen with Unreal. Stuff that works in editor, and when you play it in editor, but it doesn't work in build, even if it's supposed to. That has been the bane of my existence. But let's get back to this. All right, let's add a gizmo, and we'll have like the minimum angle for this. The minimum could be cyan as well. I think let's stay with cyan, and then it could be green when it's the maximum. Color dot cyan. Yeah, we're sticking with cyan. Actually, I say that I don't need to do that. Green. That'll be for later. And we're going to gizmo dot draw line. Here we go. And what does this take in? It takes a from. So once again, transform position plus the movement origin. There we go. And the 2 is going to be oh, my brain just had a fart there. So it is a vector 3, so it's a point that we need. So what we're going to need, let me pop back here. So what we're going to need, we have the position here, and we want it to be 1 unit in distance, or like whatever distance, based off the rotation for this that we're giving it. So I may want to do the math here. So vector 3 and pause equals, this will be this, because I want it to start from that, plus It's not transform forward though. It'll be the rotation, I guess. Wait, if I do transform dot forward, what is this? It's a vector 3. Okay. So that means I should be able to do min rotation and times transform dot forward. Okay, my brain doesn't want to right now. So let's go see our friendly, helpful Google. Considering I've done this countless times, and of course that means I can't remember how to do it. I want rotate point around origin, sure. Remind me how this works. Go ahead, Google. Right. Imagine your point is located at X, Y. If you want to rotate that point around the origin, so around that, the coordinates of the point should be located, yeah, the new X, the new Y. Cool. Where is the angle of the rotation? Where is this? So the new position is that times that? Is that true? X cos. As a sanity check, consider the point of the x-axis, rotate 90 degrees. All cos components. Oh god. You know what? I know there's a better way. I know there's a better way, and I know it has something to do with the position you want times the rotation. But I think it's quaternion. Start with a 2D. So dot rotation dot. That's a lot of math, guys. Oh. Okay. A 3D rotation. There we go. Let's bring this back over there. And hello everybody that has joined. Jeez, there's a lot of people tonight watching me struggle to remember how to do basic 3D rotations. Welcome. So we want to rotate around the Z axis for sure. Cos angle is 10. Okay, that's not what I want either. It's not. It's very well explained, but it's not what we want. I'm sure there's a way to rotate around quaternion. How do you rotate a vector by unit quaternion? Okay, for those unfamiliar with quaternion, it's worth noticing the quaternion R may be determined with the formula. Jeez. Okay, yeah, that's funny. When I check the participants, I see nothing, only me. Ikavent qua. Ikavent is innocent. I like the idea that it's showing you as inconvenient qua. All right. Let us try something, right? Actually, you know what? Farm checker. Surely I have this here somewhere. Till amount, speed, new position. Farm cell. because we did rotations and stuff. Set visual, set states, till, so, okay, farm plot, is that where we did it? Draw quads, draw lines, use, okay. Draw point A, orientation, times, the position. Yeah, an orientation is a quaternion. That's what I thought. There's a way to do it with quaternions. Okay. So let us really quickly do what actually, you know what? Undo that. Oh no. Okay. To quaternion. Can't do that. Okay, the other way around then. Quaternion dot Euler x, y, z. So we'll put in that the min rotation, and we do that times transform, and then we add that position to it. That's n position, so that should be here. Let's see what it gives us. Gren, make that green. There we go. Just hide that for now and go back, not here. Go back here. Oh, that's looking pretty good. It's reloading something, but it's looking pretty good. Okay, movement origin, that's fine, we want that there. Minimum rotation, if we move this, we're off to a really good start. Okay, Y, so I can move that to be like 90. I probably should make it those values to be like local instead of world values. So it doesn't need to be that long either. Forward, let's just do this and do it divided by 5. Yeah, that's fine. There we go. So we now have this as such. Very cool. One of the few times converting something into a quaternion makes things simpler. There we go. And now we're going to have the max rotation. This is going to be like 180, I guess. Right. And we're going to just do this again. We already have end pause, so let's just reuse that. And instead of min rotation, here we're going to put max rotation. There we go. End pause is being used. And once again, we are going to add that here. So it should be coming out in green. And what do we have? A lot of loading. There we go. So we have the minimum position and the maximum rotation. Sorry, not position. And we have it set. So we can start using this information on the door to make sure that it never goes further in either direction. Okay. And of course, if we select something else, something that isn't the cabinet, it does go away, which is what I wanted. Very good. Okay. Cool. So, back to door 1. I was saying it'd be really cool if, because I've not only seen this before, I've done this before, right? What you do is you have something save the information. So if I like select the door, I'd have a button here, I'd click it, and that would understand that that is like the position, rotation, and scale that I want it at. And then I rotate it to say over here. Oh, that's good to know. Hmm. Hmm. Okay, we'll get back to that issue. But yeah, you'd move it off to another position and you click for the end position, and then it would save that information again, and then you could be like, go from here to here. Um, all right, so it's good that we test things because I just seen that the gizmos and therefore the math doesn't quite update correctly. Let's see, because we're using the transform forward of the forward value of the transform itself. Okay. Okay. I think you have to write in chat to see your name appear or refresh the window, not sure. What? What? I'm not sure what you're referring to. I think I missed you there for a second. Okay. Right. So back to what I was saying. Instead of using the transform forward, what we could do is transform.parent forward. Parent forward. Yeah, you're right. Okay. I lost you there. I'm not sure what you're talking about, but you seem to be happy with that. So here we go. If I move this right, so this is going to use the information on the parent. Now I have a test to do, real quick. I was answering Joey. Ah, I see. I see. Okay, I'm sorry. I'm sorry. Cube. Right. So let's do a test on this cube here. We're in the testing mode tonight. If I put this limiter here on it, and we should be able to move this outwards. Interesting. Okay. So that shows me that if I put it on this and there is none, I see it. Null. Yeah. Null object. Gotcha. So let's fix that real quick because this can be an issue down the line. I'm gonna make like this huge freaking line here. But let's do this equals null. If so, we're going to use transform.position. Transform.forward, sorry. And otherwise, we're going to do transform parent. Parent dot forward. Here we go. And put this in another parentheses. We have parentheses and parentheses here. Switching BC. Yeah, no problem. So yes, depending on if there's a parent, it does things. Grab all this, copy it, put this here as well, paste it, give ourselves a little save, and when we go back here, it should stop spamming me with errors that I hadn't seen. Here we go. Select this, no errors, and where is my line? There it is. Here we go. So we have our little limiter here, and we could put this to yeah, let's put this like this, and then we can have the other one like this. Just to do a little test, and if I do a rotation on it, this one, oh, that's really weird and really interesting. And back. Welcome back. So the issue here is that it's going to use the rotation of this, so it's going to mess it up. All right. I mean, I am fixing something that isn't yet an issue. Oh, I have to remember how in Unity do you get world. World rotation? Is that a thing? Rotation. Get global rotation. You can use transform user angles to return. Transform rotation is the quaternion version of both. Yeah. No, I don't want that. Okay. Okay. I guess it would be... I guess I'm asking the wrong question here. That's my problem. So instead of having it transform forward, what I'm going to have it is... this is a vector 3. Vector 3 forward? Vector 3, is that a thing? It is. There we go. Give it a little save. Oh, hello, Carrie. Nice to have you on the stream. And now if we rotate this, yeah, this one doesn't change. That may be a problem of itself later on, but let's not worry about it now. And this one, if I rotate, it doesn't change. But if I select the cabinet and rotate, it does change. Very cool. Select that, get rid of that, and we're back to some intense math, because that's what we all want at... Oh god, it's almost 8. Almost 8 o'clock at night on a Tuesday. Cool. So now what we need, we have these, and that's pretty cool. But what we're going to need is something to keep it from going above that. Let's do it the stupid way first, and then we'll figure out what we're doing after. Oh, it's Skipmax. Stuck in Carrie's account. We're both watching. Okay. Well, hello to both of you. Here we go. You completely threw me off there. I've lost my train of thought. Here we go. Hello. Yes. Update. So what we're going to want to do is make sure that the thing never goes under the rotation minimum and over the maximum. So let's do a little test. If the current rotation, so let's do transform dot rotation. Is this a quaternion or is this a... Yeah, it is a quaternion. Local... Oh, I can't do that. Euler? Euler angles? Yeah. If the Euler angles are less than... this monstrosity... Yeah, grab this, put this here. It didn't like me doing that. Okay. Okay, let's do that. Undo. Let's get the end pause here, and we'll put it above it, and then we'll use that. Here we go. And I think the reason is... No, these are vector 3. We're good. We're good. Grab all this. Put that in. Can I not do less than? Huh. I can't do that. Carrie likes my blue blob. Thank you. I made it myself in Blender. It has a second mode. Let me just select something else. Here we go. Bloop. I'm in VR now. Bloop. I'm back. Or I think I'm back. I didn't actually see it on my end. Let me see. Let's try it again. with the actual OBS up so I know if it's working or not. Yeah, it does work. Here you go. I'm in VR, and now I'm out, and now I'm in VR, and now I'm out, and now I'm in VR, and now I'm out. There we go. Cool. End pause is that, and I can't actually do that. That's really interesting. I guess I could check like the individual angles. She likes. Good to hear. Okay, we're going down the do it the stupid route first. So X is smaller than end pause X, right? Or, and we're going to copy paste this a few times to get all the angles. I'm sure there's a smarter way of doing this. I'm not looking it up. I've looked up enough tonight. Here we go. And we're going to make this a Y and that a Z. Oh, that won't actually work. That might be one step too stupid. Okay. Let's do transform dot rotation dot Euler angles equals, I think I can do that, right? Can I set Euler angles? Is not a variable. No, I have to do, oops. Set Euler angles. Go. She was looking at an avatar like that where the voice follows the mouth. Yeah. Yeah. I think Etienne was working on an avatar like that where the voice, the mouth follows the voice. But his is in 3D, I believe. Oh, there you go. There's a few different ones. Yeah. Okay, so we have the X coordinates. So, transform dot rotation dot Euler angles dot X is smaller than I should be able to clamp this. I should be able to clamp this. I just thought math f dot clamp. Here we go. And then I have the value, the minimum, the maximum. Perfect. Okay. Dot Euler angles dot X. So that's the value. The minimum is going to be min rotation dot X. And the maximum is going to be max rotation dot X. For stream, yeah. No, they're pretty cool. I like them. And this returns what? Clamp. Tell me what it is. It's a float. Okay. So we have that. Y and Z. Okay, and I'm getting a huge underlined line. We'll look into that after that. Y. I'm probably doing this for nothing because I should read what's like appearing right now. But I don't want to. So we're doing it this way. Here we go. Z. Okay, well, what is it saying? This set Euler angles is obsolete. Instead, use quaternion Euler instead. You're kidding me. Oh. our friend Google's coming back. How do I clamp a quaternion? I don't really know quaternions either. Then why are you answering, buddy? Well, okay. Using quaternion angle. All right, now we're talking. If also you can use a vector 3 clamp vector. Oh. Oh. Oh my. Isn't this sexy? Okay, so quaternion dot angle. Let's look this up. So at the start of the stream, I did mention that I expected that this, what seems like a very simple task, is going to end up taking a while. And yeah, we're going to do it. It might take a few episodes, but we're going to do it. Okay, it returns the angle in degrees between two rotations. That's almost what I want. Transform, it returns the angle. It's not what we want. That's not what we want at all. How is he using it? If center and temp. If this angle is smaller than the max angle. Oh, I see what you're doing. Okay, so we'd see the difference in angles between those two vectors, and then after that we'd do stuff, I guess. If this camera this equals temp. The problem is that we don't necessarily know which direction we want stuff to turn. We could want them to turn like, where's my, here. We could want them to turn like this, but maybe not in this case. We might want them to turn like this, you know? So I don't think we can do that. I don't think that's the answer we're looking for here. How is the construction going? Oh, the construction's going pretty good. We got some digging done. It seems you're trying to learn quaternions while being tired. Let me try Control-C, Control-V. No, I'm not trying to learn quaternions. I'm trying to get someone else who knows how to use them to explain how to do what I'm trying to do. Because, geez, clamping quaternion rotation unity. Yeah, that's pretty much what I want. Yeah, so the construction is going well. The digging, or most of the digging, is done. Unfortunately, they had to add a whole bunch of gravel, like 900 tons of gravel, into the bottom because the land where we were building, the ground was really loose, and under that was sand, apparently. So to be able to make solid foundations, yeah, they had to dig a little bit lower, put a bunch of gravel in, compress or compact that gravel down, and then after that they could put the foundations on that. So that's done. The foundations have been poured, and they're currently standing. And we have a date for when the house is arriving. So yeah, it's going great. Right, back to this. I would have this go blah blah blah. Right. For this, you would rather use Euler angles and only convert them quaternion after applying the clamp. Okay. Directly touch individual components in a quaternion unless you really know exactly what you're doing, and nobody does. A quaternion has 4 components: X, Y, Z, and W. They all move in range of -1 to 1, so try and make this a little sense. Target X rotate equals math clamp. So he's clamping. He's clamping it, and after that, he's converting it into a quaternion. Okay. 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 I think I get it. Sure. Vector 3. Let's call this rotation, because I can't think of a better name. Rotation equals end pause. Let me think. I want to clamp something. Can you do vector 3 dot clamp? Is that a thing? Clamp magnitude. No, that's not what we want. Vector 3 length. No, that's not what we want. Okay. So we're going to reuse this here. But instead of saying set, we're just going to use the math for the rotation. Okay. And it's telling me there's errors, which is likely. Vector 3. New vector 3. Here we go. We've created a new vector 3. Perfect. Oops. Something like that. So the rotation is that, and then we're going to go back here and say set X, Y, Z quaternion. Okay, that's what we want. So we're going to do quaternion dot Euler angles deprecated Euler. Euler is what we want. Yes, X, Y, Z, and we put rotation. There we go. And it doesn't like that. Why not? There is no such argument as something that takes in. There we go. Tried to use something that was there, and that was my main error. Cool. I don't think I need end pause at all in this case. I think I've done this wrong. I think I've done this wrong. Okay, let's take a look, because that's way too much text for me at this time of night. So if I click on play right now, this should go crazy. I'm expecting it to go crazy. And it shouldn't, yeah, see. It has indeed gone crazy. And now if I rotate it, we're fine. If I rotate it further, it stops, which is what we want. Don't get me wrong, it is what we want. It's just, that's actually very cool. Like, I can't go above it and I can't go underneath it. It's just not local, not the right, you know, it's not looking the right direction. So rotation here, if I click on this should send me up to like 90, I think. Right? 90. Yeah, it sets me to 90. Okay. Okay. I think what I'm going to want to do is remember what's the original rotation. Yeah. Private. Vector 3. Init. Let me look at the shape once more. So what exactly is happening here? If I click on that, yeah, the forward is there. It's actually using the right. Good to know. Okay. So we're going to go into start, init rotation equals, and it's going to be the transform dot rotation dot Euler angles. That would be incorrect because currently it is at 0. So we want to do minus, I guess, min rotation? Minus min rotation. And we're going to use init rotation here. So this minus init rotation. I'm sorry. What's the problem here? Oh, minus dot x. Here we go. A lot of text here. Y and then Z. There we go. Does this work? It might not. It might not work. Let's see. Click on play, see what happens. Okay. Oh, it doesn't work a lot. Alright. What about plus? I'm just doing it blindly now. There we go. Let's do that. Give it another try. Because ideally we want it to start here and then rotate to that. So. Let's see what this gives us. Nope. All right. Plus, minus, minus, minus. And if this doesn't work, I'll bring out our faithful friend, paint, and try to draw what I'm trying to do. Maybe that'll help. What does that give us? Still not right. Okay. Paint. All right. So we have a problem here. We have a door, and it is looking in a direction I can't actually draw, but in that direction, like outwards, right? And 0, 0, 0 for the rotation is correct. It's that way. Oh, wait. Rotation, rotation. Parent forward, vector forward. No. No, I almost had an idea, but no, that's not what we want. Okay, let's go back here. So we have the door. It is looking that way. Now, I want to essentially zero it out so that originally this is the direction it's going in. Okay. So it's looking this way. And I want this direction, so 0 in the rotation here, to be understood as, I think this is 90? 90 in Y. Okay, so we got 90 in Y as the minimum. We have 0 for that. So rotation Euler angles. This should be... Sure. This should be the right direction. And then minimum rotation. That actually should be fine. Is the problem this? Maybe I jumped the boat here. So that should zero it out because we are using... Okay. Will be this minus the init rotation.x. I think that's what I want. Minus, 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 minus. Give that a little save. Let's try it again. There we go. If we click on play now, does that look in the right direction? This is so finicky for something so simple. Nope. I see. Quaternion rotation, this is that, and then we'll do, I guess, minus in it? We don't want this. It's because I'm not putting this information at the right place. Here we go. Here we go. Give it a little save. That's good. Right? Totally. Give it a little play. Ooh. Okay, we're not quite there. we're not quite there. Okay. So, I guess this is where we put the init rotation, the plus init rotation. So the current Euler angles plus that, let that do its, oops, x. Let that do its calculations, and then after that we bring it back. Plus that, give it a save. Not X, it said. Save. Looks like something from Bethesda. Ship it. No. Come on. They do good work. I love Bethesda games. They definitely don't do work at 8:15 at night on a Tuesday. That's just me. There we go. Let's give that a little play. And it is looking the right direction. And... Hey! Oh. Well. Well, we got half of it working. Alright. And if it goes under that for some reason... I put it at exactly 0. Am I good? Yeah. Exactly 0. Okay. Let's see the clamp. What are we doing here? What are we doing with the clamp? But it's essentially working. Cool. So this is what we're using right now. So we're clamping it to be at minimum this and at maximum this. Now negative, I think I know what the reason is. It's because we're using Euler angles instead of quaternions, which would take into account when you go under 0. Oh no. The music's dead. Wonderful. Yes, I'm still here. We're still here. We're all suffering together. Wonderful. All right. So let's just test my thought here. So if I put this to 180 and I put this to, I'm not calculating that on my own, 180 plus 90, and I press on play, it should start out sticking here, which is absolutely fine. It's normal. It's you know, we'll deal with it. And it's not working. Oh. Okay, well this is broken. Yeah, this isn't working. Huh. I'm going to have it debug error me what the current rotation is, because I'm not sure I understand what it's doing. Let's see. Besides that, has everyone had a nice day today? Filled with code that works, I hope. Okay, we are going to collapse this because that's a bit intense. And it's currently saying 90, which is what I expect at this point. Right? This is the minimum of 90. As I rotate this up, it does go up to 180, and then it sticks. Perfect. Now, here's the issue though. When you rotate this down, let's bring it back down to 0. Just so we clear up this a little bit. And we go a little bit too far. It now goes to 180. I'm a little confused. Okay. Let's have it spit out some better information. So one of these, two of those, one of these, bring that into there. Wait, rotation dot y is what we get from, let's have this angle here. That'll tell us what the angle is. Clamping between, and then these two guys over here. Oh, actually I did that wrong. It should be all of this. This should tell us what's wrong fairly quickly, I would hope. And this over here. Give it a little save. Go over to here once more. Clear it. And we already know it's fine when it hits this, so let's try going underneath it. Let's see what it gives us at first. And let's try to go back underneath it. So 90 is what we get from 90 clamping between 90 and 180. If I go the other way, 180 is what we get from, oh. I just understood what's happening. So let's turn it on to pause. I'm at 0 right now. If I go in here, you see it does go into the negatives, but what I'm understanding from that is if I do transform, rotation, Euler angles, it's not actually giving me a negative value. It's giving me like 360 minus this, which is a high number. Okay. Local Euler angles. Rotation as angles degrees. Let's see. So if that's doing, 360 minus that, let's see if we can force it to go into the negatives, because that's what we see on our end. Okay, let's give that a little test. I'm sorry? That's even worse. Okay, let's bring this down. We can't. Look at that. The numbers are staying stupidly high. It's going through... it's going into the 700s. What? Well, at least now we know what the issue is. What is this? Okay, let's try local Euler angles up there as well, but I don't think that's the issue. I don't think that's the issue at all. Okay, what does that spew out? We're taking a nice little relaxing deep dive into quaternion rotations tonight. Look at that. 802. 540. What? What are these numbers? That's not normal. So you've been working for an hour to get the door to swing? Can't you be like, hey computer, I want the door to swing, please? And the computer is like, beep boop, okay, and then the door swings? Let me see if I can, AI write code for me. See if we can get it to beep boop. Open AI codex. Here we go. Here we go. Oh, I have to log in. Well, I'm too lazy for that, so no. Yeah, I wish that's the case. I'm gonna leave. Have fun evening with your 3D chess. Yeah. See you later, it's in. Here we go. Just ChatGPT, yeah. Worst is I'm sure it could figure it out. I just have to give it very specific, like, requirements, and, well, whatever, I'm sure it's possible. But yeah, what the heck's happening with this? Oh, here's a question. Transform. What happens if I just... rotation Y? What kind of information does that spew out for us? Okay, I can't do that one. I'll leave that there then. Let's just see what that spews out for us. Okay, close this. Let's Okay, let's see what kind of information it gives us. It's still giving us into the 400 and something. But a rotation is 360 degrees. Okay. Huh. Rotation clamping between that and that. Okay, let's just pause this for now. We're not going to make it rotate. I just want to know what kind of stuff it spews out. Just without rotating. Let's just... This guy can make a door swing more than 360 degrees without the door even moving. Yeah. Okay. So, I don't know if you can see this. The door, up here, its rotation is set to -3. And it's telling me that I have a rotation of 400. And if I rotate it this way, it's staying in the 400 range. Look at this. That's a thing. Well, those aren't the right numbers at all. Can't you just copy your house door code? Yeah, I could. But what I was saying, Joe, is I really don't like how it works, the house door. It like uses a lot of physics and stuff, and it's really janky, and every time I have to change it, it just goes crazy. I want something that's more solid, that like can't go further than certain things I give it. That's why I'm working on this. And I also down the line want to reuse the code for things like drawers, so I can like not just, you know, rotate it, but if I grab the drawer and pull on it, it'll slide out and it won't do anything else but the movement I want it to. That's the idea for tonight. But I'm very confused about this number. I'm very confused about that number. I'm not exactly sure where it's coming from. Okay, let's go back over here. So this is transform rotation Y. So let's go back to our Euler angles and see what that was giving us, because there were still high numbers. Dot Y. Just give this another check. And what does that poop out? Rotations are always fun to mess around with in code, because look, they're so predictable. 802. At least the numbers go up and down in a semi-predictable manner now. What are these numbers? Okay. Let me also... rotation. Wait, no. Get rid of that for now. Get rid of that for now. I really just want to... Oops, I need to comment that as well. I really just want to know... What is this init rotation? Is that what's messing everything up? Let's take a look. Let's take a look at what that is. Maybe that's what's messing everything up and I just did it wrong. Let's give it a little play. Play mode. So, look at this. 446. Well, that's my problem. Okay. Literally just the Euler angles here at the start. What are they giving us? We are liking the vibe in the stream. Not sure if the mic or music. What kind of mic are you using? I'm using a Blue Yeti mic. This is a microphone that was generously gifted to me years and years ago, and I still have it to this day. $356. Okay. These are numbers that make a little bit more sense. Aha, and when you go over the top, I see, it goes back down to 360. Okay. So it doesn't actually take this into account. It's telling me we're at 350 right now. Right? Yes. Where this is this. I want this though. Or maybe I don't. Maybe I don't. Maybe what I want to use... It sounds great. Good to hear. Good to hear. I'm just like getting lost in thought as I'm trying to figure out what I'm going to do with this stupid door. And every now and then I'm just like, oh, someone said something. Maybe I actually have to read this. So what is he doing? He's clamping it. And then after that, he's changing it over. That doesn't work though. That's clamp rotation. This is a very specific situation. Clamp could turn it relative to plain normal. Could turn units to clamp rotations. I'd imagine it's a pretty basic collection. To be honest, I haven't used this. Okay, very. Trying to clamp an object Z rotation between 75 and minus 75, and I'm running some issues with Euler angles. Yeah, that makes sense. I use quaternion clamping function that I copy pasted somewhere. Here we go. Clamp rotation around x-axis. Ah. Okay. Set in place of Q. Okay. Where did you find that function? Mostly looked from here. Yeah, in the latest comment there's a normalization added, but I used it without normalizing. Fine. Alright, let's take a look. Scroll all the way down, I guess. So he created this guy right here. This may be our savior. Quaternion clamp, it looks like that, and we got a whole bunch of mathematics. Some fancy math in here. Bounds. Clamp rotation, quaternion bounds. I managed to go there. How is he using bounds? Tan, clamp. Q, normalize. Okay, let's drag this in. Let's drag this into our code. And give it a look. Sorry, we're distracting you. That's fine. That's fine. That's why I do streams, is to keep me from going crazy as I'm trying to figure out how to rotate things. Cool. There we go. Let's put this here. So we have this. Oh, here's the bounds. Bounds minus bounds X. Oh. Let's try it. Let's see what it does. I'm curious now. So, let's remove all this. Because it doesn't quite work as we want. Clamp. No, not that. I'm sorry. We want a quaternion. Nope, quality level is not what we want. Quaternion rotation. Yeah, it seems so ridiculous, but rotations have been just the bane of my existence since forever in this. It's deceptively complicated. So quaternion's rotation equals, and we're going to do clamp. Clamp rotation. We're going to do a little test. It takes in the quaternion, so which is going to be transform rotation. Transform dot rotation. That's our quaternion, and then we have bounds. This confuses me greatly, but I think I can change it. I think I could do a little wiggle and do this a little bit differently. But for now, we're going to leave it as this. Let's just min rotation for now, because I think I know what's happening, but I might be completely wrong. So let's put that there. Let's just see what this gives us. I want to see what it happens. I want to see how things happen. How you do things. How you do this. Should be giving us a little message down here once this is finished. Okay, 0, 0, 0, 1 is what we get from 0 clamping, because this is 0. Now if I push it in, see, we do actually have a certain amount of something. Okay. But it's not clamping in any way. No, it's not clamping in any way. Okay. So that's not how we use it. Good to know. Angle X is that. I'd like to know what these are. Actually, let me copy paste that in there so I have the basic setup for it. Oh wait, bounds is that. Wait. Let's see it again. So our bounds is 90, so I guess this goes down to like -90 or something? Okay, let's put this at 1. Because I'm not too sure how he's using the bounds. I may have to take another look at the script there. Okay, we can just keep going forever and ever. Oh, wait. I just realized we're not actually clamping it to the rotation. Okay, let's give us a rotation here, and that should force it to stay somewhere. Okay, let's give it another test and see what it gives us. No, I clicked too quickly. Bring this back. This should be 1. We'll see what that gives. I have no idea. But it should, the door should move. Oh. Hello. Yeah? Is Ada hungry?
No.
Okay.
I was told that your stream is missing me.
It's missing you? Well, come say hello to the stream then.
Hello, stream. I'm not being censored for once.
For once. Alright. Okay. So, this is... If we look up here, it's going between 1 and -1. That's actually perfect. That's actually perfect. Because... what I'm going to do here is I'm going to change this. So instead of having bounds, we're going to have min, and then we're going to have max. Vector 3 max. And we are going to put min x here. Min x, y, oops, nope, not that one. Min z. And max. And then we have the minimum rotation here and the maximum rotation there. And give that a little save. Go back over to our editor. And yes, Igly passed and said hello. And we're going to see what this gives us. Here we go. Oh. I got excited. 180, and then it goes back down to 90. Okay. Did I remove the debug log? Yes. Okay. Rotation is what we get from clamping between that and that. Okay, this makes sense once more. And then of course we're going to have to do the, minus whatever at the start that we were doing earlier. But I want to know why it goes crazy. So this is what we get from 90. 180. And it should go crazy just about now. Yeah, see? We have managed to recreate the exact same issue, but slightly differently. Okay. Rotations. Jeez, it's almost been 2 hours. I've been trying to rotate this door for 2 hours. Okay. Clamping, taking between 90 and... okay. So clamp this rotation. takes a quaternion. And it poops out what? A quaternion? Okay. Okay. I was gonna say we could set it up so that it's back to being in the right direction, but maybe it's just better to try to figure out why it's not clamping the maximum. Max X, max Y, max Z. Because when, let's go back. When we had it with bounds, right? Let's see if we can break it. So we brought it back to having bounds. The bounds are 90, so it should go between 90 and 90. Give it a little start. And it goes up, 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 hits 90, and then stop. Oh, okay. And I was gonna say, and then stops, but no, it does go too far and then come back. Huh. But it does take a while before it freaks out. Okay. Okay. So this may explain why these doors are so janky. It's not that their physics stuff is stupid. It's that rotations themselves are stupid. So if we go back here and redo the things we took off with the 90 and the whatever. Go back here and we bring this down to 0 and put that to 90. It'll start like this and then open up to 90 degrees, is that correct? Does it still go crazy after? No. And it has to go all the way around before it's a problem. Look at this. So that kind of works. Okay. Let's bring this back so it'll be 90 and 180. And I think this one just freaked out at the very end. Yeah, it does. It does. Now the real question here is this going to cause enough of a problem for me to care? Alright, let's try something. Init rotation here, we are going to do transform.rotation. Local Euler angles. Plus, minus? I can't remember what we were doing. Let's go with minus again. And then do min rotation here. take all this and make it a quaternion. Euler. Here we go. And at rotation, minus that. It might have been plus this. Plus this. So quaternion, you cannot take away from a quaternion. I swear. So if anybody was wondering, yes, rotations are hell. Rotations are hell. Why did I start with the rotation? Euler angles minus, I think I could do this. Euler angles, I can, but that's no longer quaternion. Okay, and then we'll do quaternion dot Euler. There we go. And I've completely lost track of what I was doing at this point. Hopefully when I press on play, the door will stay like this. Oh! Oh! And I can't open it. Oh, it's kind of working. Yeah, it's kind of working. Look at this. I guess you'd have to do clamp rotation with an offset in there as well. That equals this atan, got q.x over here. Oh my gosh. All right. So, I think what we can take from tonight is you know, humility is a good thing, and you shouldn't start off thinking that it's going to be really easy to make something rotate. It is now 9 o'clock-ish, so I think I'm going to call it here for now. We're going to come back to this next week, and I'm probably going to come back to this starting with the slidey drawer. You know, this guy down here. This guy that doesn't require rotations, it's just gonna slide in and out. It's just a nice little slide. Just this. And we'll get back to the doors after. So, for those of you who joined in tonight, thanks for joining. For those of you who wrote in chat, thank you for keeping me from going crazy. It's always appreciated to have people chatting there. Those of you who listen to this later, thanks for dropping by, and I'll see you next week. Goodbye.